All right, let's see if we're up and running. Anybody there? Let me know that chat's working. Also doesn't matter. Nobody's there, but getting some feedback on whether the audio is working, and that sort of thing. It's a slightly different setup. I've been usually doing these streams in the other room at a standing desk. Also getting over cold. Okay, Travis, you're always joining these. I haven't done one in a while. I was on sort of vacation, and then I was sick. And actually, that's why I was my doctor put me on Sudafed, and I'm like, okay, Sudafed, and apparently it made my anxiety skyrocket, and I didn't know what was going on. I didn't realize till just today, and since I don't really need it anymore, I'm not gonna take it, so feeling better. So this project, I actually didn't know how to describe it. Calling it a self-updating daemon is accurate, but probably not. You think of a self-updating daemon, it's like one that gets a new update, a new version is released, and maybe it replaces itself, and runs the new version. That's sort of true. The purpose of this is a little different. The idea is to have a daemon that you can actually post new versions to directly. So instead of releasing a new version and then it's watching a feed and then downloads, something like, there's some Go libraries that will do that sort of thing if you have a self-updating binary, whether it's a daemon or not. This is different. This is assuming that you have sort of a singleton daemon and you want to push updates to it. And this is to emulate let's see, is there a good concept for it? I call it continuous programming. And I wrote a library in Python that did this so that you could actually have a daemon and it would live reload modules. I guess it's live reloading. It would live reload modules as you edit them. And the purpose of this is not for some new microservice app or whatever. It's for a singleton daemon that you are using for some kind of automation, and that it's actually useful to interactively program it. And as a really cool paradigm, once I had that working, and I wanted to get the same thing with Go. Of course, you can't live reload modules in Go. So the idea was to recompile and just replace the binary. And you could get fancy with binary diffs and stuff, but in this case, we're just going to be building a system where we have a daemon. Maybe it's running on Heroku, and we have our local development environment, and this is the sort of ideal end goal. And then as we're editing code and we hit save, and normally your editor might automatically build locally, not only would it build locally, it would actually post that binary to the running daemon and replace itself. And so it basically go live as soon as possible, as soon as you hit save. And sounds crazy, like like, oh, you never do that if something in production, but I think there is arguably a lot of great use cases for that. So, structurally, there are a couple of things that we have to do. Some of this I've already started here in this prototype, but one is we need a wrapper daemon, and that wrapper daemon is going to a lot of people have done this sort of thing where, like, if it's going to reload some other binary process, it acts as a proxy so that it's listening on whatever port 80, and then it proxies to the other process, and it watches that process, and if it gets a new process from whatever means, it'll then start the new process or kill the old process and then start the new process. A couple of variations though. The idea here is that our proxy is also going to inject has a daemon, a special URL, and it serves two purposes, or it will. Right now it serves one purpose, which is a get. It actually is going to stream the logs for your daemon. So the daemon that's running, whatever output it's sending to standard out, you can get streamed to your whatever HTTP client. The idea is this is sort of a built-in log stream. So if you were to build a tool, which will eventually do a client-side tool, it can be streaming the logs, and you can kind of see the event of things closing down and starting up again, and anything that might go wrong in this sort of deployment process. I mean, really, this is just a fancy deployment mechanism. The same endpoint, we could do a put. Maybe a put makes sense with a new binary, and then it'll go and replace itself. I had crazy ideas of, oh, what if we had this actually take the source code, post the source code, it's a smaller payload, and then it builds it. It might be a faster build environment. I think that's an optimization, and turns out to be a lot more work. Travis, I don't know if you're the one that was asking about that. Somebody was asking. I was talking about building Go binaries in Go, right? The Go compiler is written in Go. You should be able to build binaries in Go as a library, but I don't think it's actually set up for that very nicely. But again, that's an optimization. Here we can just build the binaries locally and then post the binary, and then the daemon wrapper will switch out the binaries. So that's kind of our goal. Let's see what do we have. We've got a bunch of stuff here. We've got a multi-write closer. This is just stuff. I think I've written a lot of these before. A flush writer, one that will flush every time you write. Which all of this is used to just stream out the standard out. Kind of a weird. I took a weird approach to this multi-write closer. First time I used the sync map. So basically using the map as a set, and then saying basically adding new writers to the multi-write closer. And then it's going to basically, for every write, it's going to range over all of them and do a write. It's a multi-writer. There's actually a built-in multi-writer in the I/O package, but it's static, so you have to create a new one every time you add a new, which might be the way to go, kind of an immutable object. In this case, it was just easier to have a reference to something that you could add and remove. I'm just kind of reading this code here. Yeah, so the proxy, it's actually using the built-in, let's see, is there a proxy? Yeah, single host reverse proxy. So this is the wrapper daemon. and this is the proxy, so we're kind of assuming that it's listening on port 8080, and sends all requests there unless it's the daemon path. And right now it doesn't do anything other than stream the logs, which we can test here. So we have a separate package here of a simple hello world HTTP server, and it serves up hello world on 8080, but its standard out actually is going to be printing a counter. You might have seen some of the results of me testing this before a while ago. When was that? In November. Let's move these things around. I just got a notice saying that I'm not getting Google's not getting any stream data, and then it went away. Maybe it's working. Say something in chat if it's still working. I don't know if there was an interruption or what. So let's see, what do we have here? I guess we can just foobar, huh? Okay, so main.go. I think I was in the middle of writing. Hard path. Yeah. Okay, cool. Thanks for that. Oh, I should have put on low latency. That's something I forgot to do. It's probably quite a delay from when you typed that when you saw it. It's probably not a lot of viewers. It might be difficult if people see stuff that they want to help me fix, see something they need to tell me I did wrong. So I actually need to get back into the state of what I was doing here. It looks like what I was about to do, yeah, I think, and this is just kind of a first pass, I was going to, if a temp daemon binary exists, it's going to run that, and then if not, I don't know what I was going to do. So this would become temp daemon, and I guess the idea, okay, that I would give it a path to another binary, and then it would copy it in there. So this becomes like a working location for the binary that we would be running. And I guess we would just, if we get a new one, we would just write it to that location. So that seems straightforward. Why don't we finish that thought that apparently I was in the middle of. So this is, if daemon path doesn't exist, then we want to copy argpath to daemon path. And then we run into the problem of like, copying is not so straightforward. We're probably gonna have to go get a copy, go and copy file function that somebody's implemented, because I don't actually want to use a library for this, and it's kind of funny that it's not so non-trivial. Let's see. Oh, I'm curious. Are they going to add this? Travis, do you know anything about the state of copying files in Go? I mean, I guess it doesn't have to be as fancy as what most people do. Like, we kind of know it's an executable. We can basically just read it in and write it out. I'm curious, though, what was going on with this. Yeah. good. And we should not do this in the IOUtil package. Yeah, easy enough to write this bit of code when I need it. Yeah, so it looks like it's not going to be included. Lots of things can go wrong. In our case, we kind of know. Like, I think we just want to read it in and write it out. This is kind of obnoxious. So, why don't we do that? You know what, though? Someone's written this. I'm not going to sit here and write boilerplate code. Interesting. We might even just simplify what we have here. And attempt to copy a file content. Yeah. This is basically it. I don't think there's any. It looks right. Looks like what I would probably end up writing. I'm gonna kind of double check. Open, close, create, copy, close, close. Yeah. Permissions. It is an executable. I guess we can just do that as a separate operation. See, Travis. Let's do this. I guess we should also check that this file exists, but we'll just fatal. That that does not exist. I don't think I've ever written the same error twice. I feel like every time I'm coming up with a new way to say the same thing. Log fatal doesn't have. It does. Okay. I'll just do this. I have a new keyboard, so. And then here we're gonna. If it doesn't exist, then we're gonna copy. And then we'll do, I guess, chmod. I think it's just chmod, but this would be I still don't recall 7. What? Which one? Which one is execute? Unix file mode execute. Yeah, give me the octal. It's 7, right? You know, I'm, just gonna do something. What is it? Name mode. I usually have I don't know why I don't. Some kind of like Oh my god, I've been writing too much C#. Which reminds me, I have a Twitch stream that it focuses on game development. Program. I'm trying to keep these separate. I'll just kind of make sure that it's... Is that right? Can't believe I don't remember the common ones. I should just reverse look this up. I'm sure Google is just going to tell me. I feel like this is something Google should know, it should be aware of. Just be like, oh, that's this file permission. Whatever, that's right. Right? Tell me if it's wrong. Add store daemon. And then I guess we'll give the path here. So this should work the same way it did before. And let's see, we have a payload. Payload does this and shows a counter. So we'll just give it that. Seems to be working. Right, temp daemon should be there now. Yep, and it's executable. So far, so good. So now we have a daemon that we can replace. And we know that we want to do that here, but let's kind of think through what else happens. So maybe just for reference, we can look up self-updating binary. Yeah, Alan's library does a lot of stuff. Ooh, what's overseer? Creating vulnerable, aggressive, self-updating binary. Main goal. Facilitate creation of self-updating binary to play nice with standard process managers, and display small and simple API with reasonable defaults. Okay. And active process, closing and listeners passing. That's nice. Restart causes in foreground process, monitoring to incorrectly detect program crash. Attempt to solve this by using a small process to perform the socket exchangeable proxying signals and exit code from the active process. Yeah, that's basically what I want to do here, but with a little API to do the actual updating. I'm wondering how they do this. So let's see here. So this is typically how it works. You'd fetch. I don't know why I didn't see this before. I might want to just use this to kind of like handle some of the the inevitable technical details. Main process retrieves the files of the listeners described by addresses. Child process. I mean, we do want. Do they do a proxy? Child process pipes are connected back to the main process. All signals received on the main process are forwarded through the child process. I haven't done that yet, but I know that I need to do that. Fetcher runs in a routine. So fetcher is a thing that goes on a loop, accepts URL, pulls URL on change. We get the URL stream back to our overseer. Once it's received, it is run. Simple echo token to confirm it is an overseer binary. That's interesting. I don't know about that. Except for scheduled restarts, the active child process exiting will cause the main process to exit with the same code. Okay, so it's not a process manager, whereas I kind of want a little process manager. I mean, at the same time, though, if this is running on something like Heroku can restart it, or whatever process managed environment. So that's something to consider. I think the interesting thing that I'm ultimately getting at is being able to post the binary, and then how far we can take that idea. So it might be that we'll kind of work with what we got and then come back and replace it with this, since we already have something. The one thing that I wanted to see, it doesn't. I don't think it's going to do anything clever. There was something, I'm trying to remember what it was. It might not even be relevant. There was something that I remember talking to Alan about self-replacing binary, and it was something like moving the current binary to another location, putting a new binary into the existing location file path. And I think that's something crazy like execing into it, which is very much a self-updating binary. In this case, we have this wrapper process because we have this proxy and stuff, so we don't actually need to do that. So maybe that isn't relevant. So it should actually just be as simple as like, okay, if we get a binary here, we could stream it into this location, although we probably want to have a backup. So that if it can't start, if this binary that we got can't start, we'll just keep using the old one. Or let's see. Because the whole thing with you could do it in sort of in the way you would do this with like Kubernetes or something. Forget what it is, green, blue. Run the new one, and then check that it's working, and then close the old one after routing traffic to it. You could do that here, but I don't think it's really necessary. This is the problem with having so much experience. It's really hard to just like prototype stuff without thinking of like the right way to do things, because you have all this experience to kind of show you like, oh, you gotta do things this way. Maybe I'm better than most at that because I'm able to write code like this, but which is to say terrible code, but it's sort of a necessary thing for like a rapid prototyping thing. Yeah. I'm trying to think of that switching process. So let's say we write the post into this thing. We write a new file, and then we the simplest thing would be there's all kinds of tricks that we can do. Just trying to ignore those tricks. Trying to start with the dumbest thing. Kill the current child, and then start a new one. But it's sort of not just that, because if the new one fails, we need to go back and run the old one again. That's where it gets a little bit complicated. Let's try. In theory, we could actually, I mean, if we want to do the dumbest thing, we could actually stream it directly into this location, because it should be in memory. Like, it shouldn't matter that it's the binary in use. As far as I know. And sometimes there's like a lock on it. I don't think that's the case. We'll just try it. And again, the dumbest thing, we'll just try writing it to that location and then doing a restart. So we just do the obvious part, which is again, C#. If it's get, we'll do a switch. This keyboard is supposed to be better, but it's actually a giant wireless magic keyboard with a number pad. I didn't know they had that. I got it because I have been doing 3D modeling, and it's like impossible to use those kinds of tools without the numpad. But it just feels different and weird, and I keep hitting the wrong button. So we'll do put. I don't think there's any problem with that. I'll even why don't we just like test this by yeah, simplest thing, we'll just write some byte. Always simple, iterative. And yeah, we don't care about anything else. Is it? Yeah, we got this if statement I started. So we will curl a put to localhost daemon. So far, it's so good. Is this the right button? I'm not actually proxying signals. So what we want to do is we want to read in this read in a request body. We could IO util it. Read all. What could we do? I guess we'll definitely error. It's our signature again. String. We'll do something like, it's your fault. Bad. No. Now these are different. That's not the errors I'm looking for. I want status. That's right. Bad request. And that's actually the code, right? So we need the status text. Yeah. All this just for an error. Might as well log it. Not fatal. I don't never use error. Does that exist? It does, right? No? That's right, it's like print line. Close our body. So now we have some data. You know, this puts it into a I mean, we should have streamed it in, but something like this. Do I want to do that? Sure, let's do it. Let's stream it in. Good. Error. Okay, so error. We need to know what that daemon path is, so I guess we need path here as well. Actually, we probably do want to create, because we're replacing it, so this will truncate it. If there was an error, we'll just, we'll just say something went wrong. In this case, it wasn't their fault. I wonder what they do. I'm always curious what people do with the bytes written. Okay. And sometimes you check it. I mean, stuff like this where you have a multi-writer. What are you gonna do with this? In fact, not this. This. What are you gonna do with that? In this case, it looks like it just sets it over and over, so you get the bytes written to the last one that was written to. Which isn't like ideal if you're writing a good reusable utility, but what are you gonna do? It's like, what can you do? I wonder if creating is going to change the file mode. I guess we'll just set it anyway. So we copy all that in. We don't have to defer, we can close once that's done. And then probably just say okay. Although ultimately we might want to like stream the problem is we won't unless we build in a mechanism to know that the daemon is ready. I love this. There's like all these things that we know that we need these days. Like you need to check to know if a process is ready. Well, there's no way to actually know if a process is ready. A daemon. Like that's so common now that it seems like every daemon should have some common mechanism at the like kind of Unix process level of knowing when it's ready. But I guess you could have it like echo a signal or something. So this should replace the file, and so this could be disastrous if it doesn't work. Although not. Yeah, now we need daemon path. See, these are the reasons why I don't want to do this with Python. I guess there's some other reasons why I don't want to do it with Python, but I can't give up type safety. It's you know, call me lazy, but I'm just never gonna think of everything. And having that first pass, and you know, you could lint. Actually, I looked into, what was it? The type safe Python. But yeah, I mean, you can do it with a linter. Just like, it's just steps. Plus, I'm writing so much stuff in Go. I just want to keep using it, so I don't want to have to go back to Python, go back to that world. Okay, so this should work if we can figure out how to properly send a file. As the request body. I always forget because you don't do it very often. It's like curl send file. Yeah, it's like F and then maybe at in the file path. Data equals. Multi-part. I'm gonna have to parse multi-part, huh? Is that true? I am. All right. What do I have? Okay, this is what I was gonna do. I wasn't even gonna write this to a file before. I was just gonna like echo out how many bytes it was. So that's why I put it into a byte slice. All right. Well, so. Parse multi-part form. I don't know what that is. Form file. So we have the mechanisms here. Yeah. That's fine. I don't know what this is. We'll have to look that up. Max memory. Call request body is parsed, and up to a total of max memory bytes of its file parts are stored in memory, with the remainder stored on disk in temporary files. Yeah, this makes streaming very difficult. I mean, we don't have to do it as a multi-part file. We could just curl send standard in. Read from file or standard. Some of these will be out of date. It's kind of surprising. Yeah. Data binary. Yeah. And then we can just stream from the request body. I mean, let's do that for now, right? Right? We don't want to mess with the multi-part stuff. You can't stream it, as far as I know. I mean, you can do anything, but standard library is not going to do it. So this one's already running. It's been running. And what we have? Payload. Can we do this? Seems kind of big. So yeah, we could curl exput data binary. Fuck that. We'll do this. And see what happens. Now, it's not going to restart or anything, but the interesting thing is that does that still work? This guy's still running. It did start though. I guess we don't. The timestamp looks right, actually. And it kept all the fire mode stuff intact. So if we do the reset, the restart code, then we can ensure that we're actually setting a new binary, because we can change the output of that program. And that finally gets at kind of what we're really trying to do here. So we'll like change counter to something else. So after it's been written, it says okay, we have to restart our daemon. And we don't have a good way to do that. I mean, I'm thinking of just doing it like a package global reference to a command, just because like we're already changing, because we'll refactor all this later anyway. Once it's sort of working, we know the structure of the problem, and we can write a better abstractions for it. So we do run, can we kill in another one? I guess this will also cause it to die. So we'll have to, right, we have extra steps of if it dies, we have to roll back. We can do roll back later. So it's almost like we don't even care that that it's running. I mean, we might as well just have like a package level command, you know? And then just, you know, do this here equals command start, you know? Don't need to run it in a go routine. Don't need this. Oh, crap. Oh, no, then we have everything. Standard out and standard error. I'm saying we have everything to do this again. So we would... it's funny. Killing a process is also non-trivial. You want to send a signal, and then wait, and then send a kill. I think in our case, we'll just kill it. We'll come back to doing this right later. We'll say okay. We'll actually return okay after we've done all this. So we should be able to do like not kill. It would be process kill, and yeah, we can get this error value out. I should probably do an HTTP error because I'm doing this so many times. Kind of obnoxious. I guess we also need the writer. And then we can throw in all of this. I guess we don't necessarily have an error. No, we do have an error that we're printing out there. Status code though. Right, so then this can be status, removing some redundancies. Yeah, HTTP error. Okay, so now we can do this. Nope. Yeah. Bad request. I guess we need to know if we want to return, right? But I guess. I'm sure there's a better way we could structure it, but mean, as kind of gross as this is, it's so much better than like doing callbacks or some stupid fridge. Looking at you, every other language. Okay, so we kill it, kill the process. We'll just override this variable with a new thing. We'll assume it's working. And let's see. Do we use that path anywhere? Oh, I guess we do. Yeah, and then we just, start it. No, we have path. Where is path? Do we not have path? Daemon path. I mean, we also might want to like give it a little bit of time. No, fuck it, we'll try this. So it's running. 1, 2. Then we post it. And then we start. And again, this looks like it went really smoothly, but of course this is sort of like best case scenario. We're not programming defensively, we're just trying to get this to work. We really have a lot of work to do to make this, robust code. Robust. But so now this could be running here, and we could recompile payload where instead of counter it says foobar, right? And so we're like, go build, and then post it, and now it says foobar. So there it is. That's what we set out to accomplish. Ultimately, though, this is just the beginning. I think I'll keep going. Some of the stuff that we want to do here. Okay. We can get rid of that. I mean, now that we're here, it's sort of like, oh, that was easy. Less than 200 lines of code. Again, best case non-defensive code, but let's keep pushing on the interesting part. What I'm trying to do, my goal is I can edit this file and hit save, and as quickly as possible, the running version will be replaced with this. So trying to decide, should we, for this prototype, should we be working with Atom and have Atom, instead of just build, it will build and then also do the curl, or would we have like a separate process that watches these files. I think ultimately I'm going to need a watcher. That watcher can also stream the logs. The watcher would also have to run the build. That's just shelling out to go, since that's apparently one way to do it programmatically. Let's see. We could do that pretty quickly, I think, within 30 minutes. So when did I start? 4:30? In theory, I could go another hour, but let's see if I can do this in 30 minutes. Let's go. I guess I should put this all on GitHub when I'm done. I might be lazy though. If you want the source code, comment, and then I'll put it on GitHub. Nobody says anything. It's sort of like, just wait, because this is kind of a prototype for something else. I don't really feel like putting this code up, even though I created a whole account specifically for this like prototype code that I was using in previous streams. Just kind of feel like if you want the code, ask for it, and I'll put it up. I guess we'll call it a watcher. And we want none of this. File watching. Okay, so okay, well, we'll take a path and then we'll watch the path. Which I did that before. I wonder if I can get to this. I guess it'd be in Calm Lab. Everybody do your duty. Net neutrality. Your duty is not to ignore that banner, but to actually feed it. Suture stat notified changes. Where did I write this? Notify changes. Directory extensions only create and the callback. This is a good function. I could use this function. YouTube's telling me it's not receiving data again. I don't know if I can't trust it. And then it says it's good. Same thing with chat, although I haven't seen any chat things that say like, chat disconnected. I don't quite understand. I guess if I'm saturating the internet with my stream data, it's like can't get some packets through or something, and so there's like packet loss, I don't know. I'm not using anything special here, right? I guess I am. Just notify package. Fuck. Huh, that's weird. I thought I wasn't using those. I thought I was just doing the typical loop. I guess that's how I originally wrote it. Alright, well, I'll just grab this. I don't need that package though. There's a bunch of stuff in this runner that I probably want at some point. Let's see, what do we have here? It looks like we ignore get directories. Yeah. So how's this compile? Does this run? Declared not used? Word. And then how did I use this? Build and run. Okay, so I just gave it a... I'll just grab this code. That's weird. Does that work? Notify watch, dir. We can do that. ... Okay. Let's do that then. And then yeah, just the Go files. Only create, no. All changes. I can do something like, hey, changes. Again, this keyboard killing me. Gotcha. Right, okay, so we'll do a new tab here. Guess we'll just go run it. Giving it the payload directory. So it should just sit here, and then let's see while I change this file. Set this back to counter. Hey, it changed. Perfect. So that's good. Why don't we have it build it now? How do we know how to build? I guess just go to that directory and go build. And then, see, it'd be cool if we could stream the build. I mean, I'm sure Go build doesn't stream binary, it's a batch operation, but yeah, at least it wouldn't have to hit the disk. You know, we could just like stream it in and stream it out. Super big on that. Alright, well, I'm gonna run go build. I know I have some code in here that does that. Nothing fancy. So although probably want to change that directory, right? Can we do that? Change directory? What is arms1? Guess we should get another fatal. I'm always curious what people call this function. I used to call it a search. People didn't seem to like that. I don't like fatal though. It's like this fatal. Sort of sets it up for failure semantically. We could just, I guess we can specify the binary. Yeah, let's do that. We'll just call it, I don't know, .build. It's a temporary file. We'll delete it afterwards. Let's see. I mean, in this case, we don't actually want fatal, but we'll just run with it. It's not exactly what we want to do either. Build. Okay, so here we want to stream it up with HTTP now. This should be pretty straightforward. Yeah, we're doing good on time. Let's get a client here. I don't even have a put. Want to create the request, right? New request. Ooh, how easy. Again with this. Won't hard code the address for now. Oh man. You have to open that file. See, if this could have just been like a bytes buffer or something. Oh well. Like, it'd be cool if Go build could get to standard out. Not yet. I mean, imagine we want to close it before we remove it, right? So, excuse me. Where were we? And then send it off. How do I do that? Do I just create a client? Just a normal, everyday client? do that. I guess I should output the response, right? It's not gonna be easy, is it? Also, I imagine it's not liking this. It's not liking this. What is the response? Status, body, read closer. Right, whatever. Ignore the error. Read all response body. Yeah, didn't like that. Maybe that. It's just, I know I'd seen that before. I mean, I guess it's just like, oh, I can just wrap it in the parens, right? Okay, so and what? Like I just edit files now? Is that it? It'd be sweet if this just worked. It's building. I think it's building. And it's then okay. What's this output? I guess that's the there was no output from go build. Is that bytes? I didn't realize. So now that that works, you can kind of see how fast this gets deployed locally. And save. And pretty fast. That build though, that build. So we're getting there. So imagine this server that's running on the right, but that's running on Heroku or something. In fact, I'll probably just try that next. I don't know if there's time to do that here. No, there's probably not time. If I had done it recently, then I could do it, but so running in Heroku, and then locally I'm just like, edit some code, hit save, and then it's live on Heroku. in however long it takes to compile, basically, and post it. This probably takes longer to compile than to post it. My computer's not super fast. I guess that's it. I expected this to take longer. And obviously there's a lot more work to do, but yeah, the basic idea is working. If anybody has questions, feel free to comment or message me on Twitter. I do a lot of these. These are all going into something cool. These aren't just like for fun prototypes. I mean, I'd probably get a lot more viewers if I was doing like straightforward tutorials. But I have stuff to build, grandiose stuff. All these little things all will add up. So hopefully you can kind of follow along and learn something along the way or help out. Like, hopefully you get something out of it. But I'll be streaming these, and I'll keep working on this publicly like this in some future streams. So that's it for today. Feel free to subscribe and hit the little bell button to get alerted when I go live, since I don't have a regular hours yet, but I'm gonna get to that point pretty soon. Just kind of stream whenever. So that's it. Let's see this one more time. Yeah. Change serving. Serving on save. Running build. Posting. Oh, did I kill it? I think I killed it. Oh, it might be that once it's already in that directory, it can't change that directory again. So this is actually only working once. Let me change that. Okay. Didn't change. There we go. No, it's still not. Hey, what's wrong? It's watching payload, right? Could be stuck building. I should probably have it output some like status messages. See, now somehow I broke it. It's as if the iNotify stuff stopped working. Changes to that directory and then watches for changes. Like, we didn't really change anything about that, right? Remember when it was working really fast? Now it's not working at all. I liked it when it was working really fast. I guess if I change into the directory, so I don't want to do this now because I'm already in the directory. I want to say all the current directory. Obviously, that's what we changed. Of course, it was the one line of code that we changed that broke it. It just wasn't obvious. It should have been, because it's always the change. Okay, now it works. Changed building. Let me see it there. Cool, it's working again. I fixed it. Alright, that's it for today. Hope you enjoyed this. Again, if you want this code on GitHub, just comment, send me a message, whatever, and I'll put it up. Otherwise, have another chance to get in on this as I develop it in future streams. Later.